Welcome back, all my subscribers and viewers. Thank you for your patience. I have a series of videos for your development, both educational and spiritual. Please remember to like and share with all your colleagues, near and far. Now, let us venture into the world of cargo planning. Now, first, let us get acquainted with some terminologies that are used in this course. First, let us look at the angle of repose. Now, this is the maximum angle to a horizontal surface at which granular cargoes will remain without sliding. It can range from 0 to 90 degrees. The form and structure of the material affects the angle of repose. In other words, if it is smooth, rounded sand grains, those cannot be piled as steeply as can rough, interlocking sand or gravel. Now next, let us look at broken storage. Now, as you know, broken storage is unused space caused by the awkward shape of cargo. And that was seen in one of our videos, Realistic Scenario Part 1. Similarly, capacity. Capacity can be seen in our video, weight and conversion factor. Now, capacity is basically space available to load all type of cargoes and is basically the quantity of cargo the ship can carry or the volume of space the ship has for cargo. Next, let us look at center of buoyancy and center of gravity. Now, center of buoyancy is the center of the underwater volume of a vessel. Now, it is a point through which the buoyant force of the water acts vertically upwards. Center of gravity is the point at which the entire weight of a body acts vertically downwards. Now let us look at this diagram. Now here we see a vessel that initially was in a state of equilibrium, state of perfect balance. We see where it has been tilted. Now this tilt we call the angle of heel, which is, well, we have, as you can see in the picture here, we have exaggerated the whole angle to show you where it is or it would affect. Now the point of intersection between an imaginary line drawn vertically through the center of buoyancy of a floating vessel and corresponding line through the center of buoyancy when the vessel is tilted. So that would give us the angle that it would have tilted. We have drawn it through M, which we classify as the metacenter. Now, as you can see, there is G, center of gravity, and so GM is that line, which is the distance between the actual center gravity of the ship and its metacenter. Also, we can see GZ, which is defined as the horizontal distance measured in meters between the center of gravity and the vertical line that is drawn through the buoyant force B acting through the center of buoyancy when the ship is heeled, when the ship is at that angle. Now, the angle that we're talking about that would have caused the tilt or the incline is the angle classified as theta. It is the angle by which the vessel would incline out of a position of stability. As we work through these calculations, we will see how we can actually fix this effect. So we have the metacenter, we have the metacentric height, GM, we have the righting lever arm, which we call GZ, and we have the angle theta. All of these are expressed in this diagram. Now let us look at a condition that can be created when we have a large GM and hence we'll have a large GZ. Now here we have a large GM on this diagram and a large GZ, which would lead to the ship becoming stiff. We call it a stiff ship. And this condition will occur when the vessel has heavy cargo loaded near the keel, loaded in the lower part of the vessel. There is another condition, as you can see in this diagram, where we have a small GM and we also have a corresponding small GZ. In this case, we say the vessel is tender. We have a tender ship. This is where it occurs when there's heavy weight loaded up high in the vessel, that is between the twin deck or on the actual deck of the vessel. Let us look at some other things that affect the cargo. First one we're going to look at is condensation. Now, condensation occurs when warm air comes into contact with cold surfaces, or when there's too much humidity in a particular area, then the air will turn into water. Density, as you know, mass per unit volume, and we will be utilizing density as because we are going to be dealing with water, different type of water, whether it be fresh water, relative density of water, or we're looking at straight salt water. Either way, we will also be looking at the dead weight, which you can visit the video that says weight and conversion factors on Lane's ED enhancement, and it will tell you some about the dead weight, the weight of a ship, including fuel, cargo, water, stores, crews on board. And these are information which you would get straight from the shipbuilders or the classification society. Right, as we said, density is really a measure of compactness. So we're going to be looking at those two. Also, another term that we're going to be looking at is the term displacement. Now, displacement is actually the weight of the vessel, including everything on board at a particular draft, at a given draft. That would give us the displacement. So now let us look closer at the vessel. Here we are going to be looking at both draft and freeboard. Now, the draft of a vessel is the vertical distance from the water line to the bottom of the keel, bottom of the vessel, the draft. Freeboard, on the other hand, is the distance from the water line to the lowest watertight deck, which is usually found at the stern of the vessel. We are going to be looking at, again, two scenarios. Heel for one, and list. Now, heel is when the vessel is inclined by an external force, which leads to rolling from side to side. List, on the other hand, is when the vessel has more weight on one side than the other. Let us look at some stress that affects the vessel. These two frequent ones are famous ones. Again, stress. And this is one where the vessel is riding higher at the midpoint because too much weight is at the bow and at the stern. Too much weight at both ends. So it leads to the vessel riding high at the middle point. Sagging, on the other hand, could be considered the opposite of that, is one where the vessel is riding lower at the midpoint because too much weight has been placed there. Let us look at two types of load. First one, static and dynamic. Now, static load is when the vessel is not moving. Vessel is not moving. It is the main factor causing stacking pressure, which can lead to the bending and the buckling of the particular cargo that is on the bottom layers. Dynamic load occurs when the movement of the vessel, especially if the cargo that is on the vessel or in the container or in the vehicle, is not properly secured, can lead to this type of pressure, the dynamic pressure, right? Moving on, let us look at particular tank scenario. Now here we have a cargo tank and we have all the instruments that are used to measure and sounding, and we see a particular word here, OLED. Now, OLED is the void space in the tank which is measured from the top of the tank to the upper surface of any particular fluid. Now, these are a few of the terminologies. There are more, but I'm going to ask you to continue to read up anything related to cargo planning, some relevant things, and most of all, please remember to subscribe, to like, and to share. Please remember to subscribe, to like, and to share with your colleagues, like I said earlier, near and far. We thank you for your patience. And again, as we proceed with this video, I can guarantee you that you're going to enjoy going forward. See you next time.